Every manufacturer. Both individually manufacture their own standard cases. Different manufacturers. It is impossible to communicate between devices, because the data can't understand each other. But you will find, the whole world can't just buy equipment from one manufacturer. That's an exaggeration. So, our network actually developed in the beginning. Very severely restricted. So let me tell you this. We'll refer to one of our reference models today. Every time I tell you about this model directly, it may seem abstract to everyone. Every time you start learning, you must start with the model. Every company I just talked to you about. Every manufacturer. Per manufacturer. They have their own standards. It corresponds to the model we are going to talk about today. Because this model is to define the standard of our overall network communication. So everyone learns the model. The first thing to know is that the core problem it solves is, when the world follows a set of models for network communication, then in fact it constrains the various manufacturers, their ability to create their own communication standards. Then it is mandatory for us all over the world. All manufacturers follow the same set of standards to produce and manufacture equipment. So in the future we will be building a network. And the network will be traceable when it develops. There is a saying called, the real enemy of mankind is disorder. When an industry wants to grow rapidly, or to a certain extent, then it must have a set, complete communication standard. Then in our entire curriculum, the first thing we learned was the OSI 7-layer model. To us, at the stage of model making. In fact, business growth is very slow. It's just that we're Messier. Business will grow faster. Which is now for our entire network. We used to have a lot of standards. You can simply take a look. Our once popular IPX standard. First, let me introduce the relationship between them. When we explain the course, we will explain a set of reference models. A 7-layer reference model called OSI, also known as Open Systems Interconnection. Then we explain it according to it because it will be more detailed for the network level division. But what we actually use now, all communications equipment in the world, the only set of industry standards followed, a model called TCP/IP. Everyone should know this. That is to say, we will explain the course according to OSI. But actually we now, using the TCP/IP model. Well, these have been eliminated as originally. These are some old network models. But some of what we said was once. Why are there so many? In the early days of our overall network development, there is no set of standards in the network industry. Therefore, a set of standards is urgently needed. Standards proposed by brands, manufacturers, or organizational units. Everyone doesn't care about this. As long as there is now a set of standards available worldwide, all equipment is standardized. As a consumer, one of our thoughts. So around 1977, ARPANET proposes a set of standards called the TCP/IP standard. Just want all network devices. In the end, communication is carried out according to this standard. But it was not adopted. Because for each manufacturer, in the midst of development, suddenly come up with a set of standards. Then it is equivalent to all their equipment cannot be used. Manufacturers' equipment have their own standards. So it won't follow other standards. But you will find the whole trend of our world as a whole must be in order. Standardization is an irreducible step. So, ARPANET as the originator of the network model They continue to push their own TCP/IP model all the time. Until the second half of the same year. The OSI model was also proposed. ISO's International Organization for Standardization. This ISO is actually the formulation of our entire industry. Industry standard. That OSI is just one of the standards they propose. This organization is specialized in setting standards. It just so happens that they also set the standards for the networking industry. Nothing more. These two are the network models we are going to learn. So what is a network model? That is to say, our current network. What set of standards will be used for communication in the future? For example, I am now going to generate an application data with a lecture program. How should each layer of this application data be encapsulated? How to transmit the final data in accordance with our network communication specifications. How to achieve communication according to our set of standards. This is the model that exists for communication. The meaning and value of existence. The communication standard we actually use now is TCP/IP. Let me stress again. When we explain, we will start with OSI. So let's make a network model. Like our OSI reference model today. Just for first unify a standard for our current overall technology. Next, we will divide the hierarchy. What function should we accomplish in each layer? Make a command. The third convenience is to teach everyone now. If the overall knowledge of the network is framed, smashed together to talk, it will be difficult for you to understand. Then according to our current level of division, I will tell you about each layer individually. Then it will be easier for you to understand. So it is from the teaching direction. Is also relatively simple. But actually OSI is more about helping us provide a means of fault location. In the future, when everyone learns IE, they will go to the experiment. If you haven't worked yet, no real troubleshooting experience, then maybe a little blur on it. Then in the future, you will execute it when you arrive in IE. Or will go to the configuration of some experiments. Then you need to quickly locate. For example, there is no internet connection. Where is the network not working? We need to troubleshoot quickly. We generally have two methods. Top down. Then bottom up. Generally speaking. If we rule out layer 2 failures. Layer 4 failure. Generally speaking. We can quickly locate. Now it's a 3-tier fault. Because the upper 3 floors we will talk about today. It has nothing to do with our network communication. That is when we troubleshoot. We're not going to see if there's a problem here. Then look up to see if there is any problem. Then look up. Usually not so. We all read above and below. If there is no problem above and below, that's the problem in the middle. Since the division of each layer is very clear, then each layer will have some fixed inspection methods. It will help us to quickly locate network faults in the future. This is the meaning of the existence of the OSI reference model. Then we start to formally talk about this model. The OSI reference model has 7 layers. This is mandatory for everyone to remember. Must meet. NA this stage as a whole for 1 month. You have to remember these 7 layers. First follow us from the bottom first. The physical layer. We call it the first layer. Further up. This is called the second floor and the third floor. Suppose I learned a layer 2 technology. We usually mean I learned a technique of data practice floor. Suppose I learned a 3-layer technique. Actually means I learned a network layer technology. What we are learning refers to the hierarchy in OSI. We just talked about a model called TCP/IP. So although we now using this set of models, but it's in the whole model. For our 7 layers, a merge. It merges our first and second layers into one network interface layer, or data interface layer. Layer 2 refers to the network layer. Layer 3 is the transport layer. And merge the upper 3 layers into one application layer. We call it the big application layer. So although we are using TCP/IP now, but when we call it technology, it's not called according to the second and third layers. We are still in accordance with the second layer. Is the data column drop layer. The third layer is called the network layer. Here are some habits of our spoken language. The future of our overall data communication. According to our overall hierarchy. Hierarchy means that each layer is carried out sequentially. Let's go back to this picture. Let's start to explain layer by layer. I first talk about the most basic physical layer. For the physical layer, it is slightly easier to understand. For example, for the most basic physical layer, the physical layer studies. For example, how is the computer connected to the switch? What is this device in the middle? Or the middle wire is a network wire. We call it twisted pair. Inside is copper core. Then why do I plug in a twisted pair and it can communicate? Think about this. Where did this rule come from? This is the standard defined by our physical layer. If for the future, how does it transmit data? We're going to stipulate now. Such a line. How did it get on our device? As a network device. It has a network port. This network interface on our computer is called a network card. Now this crystal head has to be plugged into the network ports of both of us, so that communication can take place. This network port is an indispensable element in communication. It is also defined by our physical layer. That is to say, there is definitely not a random line in the middle. There are also production standards. When the network cable is produced, we also have the order to say so. These things are specified by our reference model. That's actually done by our TCP/IP. In this reference model, in the network interface layer, physical layer specification. But we are still talking about OSI.